Welcome to our mini project. Today we are building a complete text analyzer tool from scratch. This command line application will analyze text files, counting words, lines, characters, and providing useful statistics. You'll learn file handling, string processing, and how to create professional command line interfaces. Let's start by understanding what our text analyzer will do. It will be a command line tool that reads text files and provides detailed analysis including word count, line count, character count, and even identifies the most common words. Our analyzer will count total words, lines, and characters. It will calculate average word length and find the most frequently used words. We'll even add a reading time estimate feature. This project covers file operations, string manipulation, data processing, and user-friendly output formatting. Before writing code, let's plan our project structure. Good organization makes code maintainable and professional. We'll break our analyzer into logical functions, each handling a specific task. Here's our project structure. The main function orchestrates everything. We have functions for reading files, counting words and lines, analyzing text patterns, finding common words, and displaying results beautifully. Each function has a single, clear responsibility following best practices. First, we need to read the text file safely. File operations can fail in many ways. So we'll use proper error handling to make our tool robust and user-friendly. Our read file function uses a with statement for automatic file closing. We specify UTF-8 encoding to handle various text formats. The try block will be expanded to handle potential errors. We handle three types of errors. File not found error when the file doesn't exist. Permission error when we lack read access. And a general exception for unexpected issues. Each returns none with a clear error message, preventing crashes. Now let's count words in the text. This seems simple but has important considerations. What counts as a word? How do we handle punctuation? Let's build a robust solution. The simplest approach uses split, which separates text by white space. This handles multiple spaces, tabs, and new lines automatically. We return the count of resulting word fragments. For more accurate counting, we use regular expressions to remove punctuation first. This prevents words like hello and hello from being counted separately. We filter empty strings to ensure accuracy. This enhanced version handles edge cases better. Counting lines and characters is straightforward, but we'll provide both total character count and count without spaces for more useful statistics. Line counting splits text by new line characters. We remove trailing empty lines to avoid inflating the count. This gives accurate line numbers matching what users see in text editors. Character counting returns both totals. Total characters includes everything. Characters without spaces removes spaces and new lines for the actual text length. We return a dictionary for organized data. Let's add advanced features that provide deeper insights into the text. We'll calculate average word length and identify the most frequently used words. Average word length sums all word lengths and divides by word count. We check for empty text to avoid division by 0. This metric indicates text complexity. Longer words often mean more formal or technical writing. Finding common words uses Python's counter class for efficient counting. We convert text to lowercase for case-insensitive counting. Common stop words like the and are filtered out to focus on meaningful words. The function returns the top n words with their counts. A useful feature is estimating how long it takes to read the text. The average reading speed is about 200 words per minute. Let's implement this calculation. Reading time calculation uses the standard 200 words per minute rate. We format the output based on text length, seconds for very short texts, minutes for typical documents, and hours for long content. This provides readers with useful expectations about time commitment. Professional tools present results clearly and attractively. Let's format our analysis results in a well-organized, easy-to-read display with proper formatting. Our display function creates an attractive header with borders. We center the title and show the file name being analyzed. Visual separators make the output organized. We display basic statistics with proper formatting. Numbers use 1000 separators for readability. Averages show 2 decimal places. Each statistic is clearly labeled and aligned for easy scanning. Finally, we display the most common words in a formatted list. Dots create a visual leader between words and counts. Numbers are right aligned for clean presentation. A bottom border completes the professional output. Now we need a main function that orchestrates everything. It will get user input, call our analysis functions, collect results, and display them beautifully. The main function starts by reading the file. We provide user feedback about what's happening. If file reading fails, we return early. The read function already displayed the error message. We call each analysis function and collect results. This modular approach makes the code clean and maintainable. Each function has a single responsibility and returns specific data. We package all results into a dictionary for organized data passing. This structure makes it easy to add new statistics later. Finally, we pass the complete stats dictionary to our display function for beautiful output. Let's add a command line interface so users can run our tool easily. We'll handle command line arguments and provide a friendly interactive mode if no file is specified. Our CLI checks for command line arguments. If a file name is provided, we analyze it immediately. Otherwise, we enter interactive mode and prompt the user for a file name. The if name equals main guard ensures this only runs when executed directly, not when imported. Let's see how all our functions fit together in the complete project. Here's the organized structure of our text analyzer tool. Our complete project includes imports at the top, file input-output functions, basic counting functions, advanced analysis functions, utility functions for calculations, output formatting, and orchestration functions that tie everything together. This organization makes the code professional and maintainable. Let's test our text analyzer with a sample file. We'll create a test file and see how our tool analyzes it, demonstrating all the features we built. First, we create a sample text file about Python. This gives us realistic test data with multiple lines, varied vocabulary, and typical sentence structure. We can run our analyzer from the command line by providing the file name as an argument, or run it interactively and enter the file name when prompted. Both methods work seamlessly. Here's what the output looks like when we analyze our sample file. Notice the professional formatting, clear organization, and useful statistics. The output shows all our statistics beautifully formatted. Word count, line count, character counts with and without spaces, average word length, and estimated reading time. The most common words are displayed with visual leaders connecting words to counts. Everything is aligned and easy to read at a glance. Our text analyzer is functional, but there's always room for improvement. Here are some exciting features you could add to make it even more powerful. You could add batch processing for multiple files. Export results in different formats like JSON or CSV. Analyze sentences in addition to words. Calculate vocabulary richness. Detect the text language. Create word cloud visualizations. Compare files for similarity. Or support various file encodings. Each enhancement makes the tool more versatile. Let's implement one enhancement. Exporting results to JSON format. This allows other programs to easily read and process our analysis results. The JSON export function adds a timestamp and writes all statistics to a JSON file. We handle errors gracefully and provide user feedback. The main function can prompt users if they want to export results. This makes our tool more flexible and integrable with other systems. Throughout our project, we've implemented comprehensive error handling. Let's review the key practices that make our tool robust and professional. Our error handling follows best practices. File operations are wrapped in try-except blocks. We catch specific exception types for clear, targeted error messages. The tool degrades gracefully, continuing operation when possible. Error messages are user-friendly, not technical. We return none or defaults on errors rather than crashing, ensuring our tool never fails unexpectedly. Good code organization makes projects maintainable and professional. Let's review the organizational principles we followed in building our text analyzer. We followed 4 key organizational principles. First, each function has a single, clear purpose. Second, we use descriptive names that immediately tell you what each function does. Third, every function includes a doc string documenting its purpose. Fourth, we group related functions together logically. These practices make code easy to understand and maintain. Let's explore practical scenarios where our text analyzer tool provides real value. These examples show how your project solves actual problems. Content writers use it to check word counts and estimate reading time for blog posts. Students verify essays meet assignment requirements. Data analysts get quick statistics before deeper analysis. Authors track writing progress and identify overused words. Professionals ensure reports meet specified length requirements. Our tool serves diverse needs. For small to medium files, our analyzer performs excellently. But what about large files? Let's discuss performance considerations and optimization strategies. Our current implementation handles files up to 1 MB quickly and efficiently. For typical documents, performance is excellent. The with statement ensures memory efficiency. For larger files exceeding 10 MB, consider processing in chunks, using generators to reduce memory usage, implementing parallel processing, and adding progress indicators to keep users informed during longer operations. Here's an optimization for handling very large files. Instead of reading everything into memory at once, we process the file in manageable chunks. Chunked processing reads the file in 1 MB pieces by default. We append each chunk to a list, then join them at the end. This prevents memory overflow with huge files. The chunk size is configurable for different scenarios. For large file processing, users appreciate feedback. Let's add a simple progress indicator to show the analysis is working. A simple progress function displays animated dots to show activity. It overwrites the same line using carriage return for a clean effect. We call it at key processing stages to keep users informed. This small addition greatly improves the user experience, especially for larger files that take more time to process. Before considering your project complete, test it thoroughly. Here's a comprehensive testing checklist to ensure your text analyzer handles all scenarios correctly. Test with empty files, files with only white space, very short files, typical documents, and large files. Test error cases like non-existent files and permission issues. Try different text encodings, special characters, and various punctuation patterns. Comprehensive testing ensures your tool handles real-world scenarios reliably. Let's recap what we've accomplished. We built a complete, professional text analyzer from the ground up, incorporating numerous important programming concepts. We covered file input and output operations with proper error handling, string processing and manipulation techniques, comprehensive error handling and data validation. We used dictionaries and lists effectively, implemented regular expressions for text cleaning, created a command line interface, organized code into modular functions, and formatted output for professional presentation. This project demonstrates real-world programming skills. Beyond the specific Python skills, this project teaches important programming principles applicable to any software development project. We learned modular design by breaking complex tasks into simple functions, defensive programming by anticipating and handling errors, user-centric design by creating clear interfaces, code documentation through doc strings and comments, and iterative development by starting simple and adding features progressively. These principles apply to all software projects. This project is just the beginning of your Python journey. Here are directions for continued learning and skill development. Continue with advanced Python topics like decorators, generators, and context managers. Explore data science with pandas, NumPy, and visualization libraries. Dive into web development with Flask or Django, REST APIs, and databases. Learn machine learning using scikit-learn, TensorFlow, and natural language processing. Master testing and DevOps with ptest, CI/CD pipelines, Docker, and cloud deployment. Each path builds on the foundation you've established. Remember, every expert developer started exactly where you are now. Building projects like this text analyzer is how you transform from beginner to professional. You've taken the most important step, building something real. Every line of code you write makes you a better developer. Keep building projects. Keep learning new concepts. Keep sharing your work with the community. The best way to learn programming is to build projects you're proud of. You've proven you can do this. Your text analyzer is evidence of your growing capabilities. Be proud of what you've accomplished and excited about what comes next. Your text analyzer project is complete. You've built something amazing. Now take what you've learned and build something even better. The possibilities are endless. Keep coding, keep creating, and keep pushing your boundaries. Happy coding, and congratulations on this achievement. Thank you for following along. Now go build something incredible.